Good morning, everyone. My name is Vanilla.
And I'm Harish.
So, we are presenting this project on microcontroller based simulation of a washing machine, which is developed and tested using Pixim Lab, which is a powerful simulation tool. The simulation shows how real world embedded systems work by controlling peripherals like keypads, LCDs, and buzzers, which are similar to a real washing machine. We have built this system using C and embedded C in the software MPLAB X IDE, which is specifically used on the PIC16F877A microcontroller. So coming to the introduction, this project is a simulation of a real world washing machine, but instead of using actual hardware components, we built it using software tools that emulate hardware. We used a microcontroller, specifically the PIC16F877A, to serve as the controller of the washing machine. Through this simulation, we demonstrate how microcontrollers interact with components like keypads, buzzers, and displays to automate washing machines, just like in real washing machines you find at home. The simulation is done using Pixim Lab, which mimics how these devices would behave without requiring physical setup. This project helped us bridge the gap between software programming and hardware control, giving us a practical understanding of embedded systems. So, when coming to the program languages which are used in this project, C and embedded C. So basically, we know that C is a high level language, but it has low level capabilities, which make it deal for embedded systems programming. It gives precise control over memory and registers. Now, coming to embedded C, it is an extension of C that lets us direct access microcontroller hardware, such as input to output ports and timers. It supports features like register level programming, bit manipulation, real time constants using timers, interrupt handling. For example, using embedded C, we can write something like port B is equals to 0 into 01 to turn on an LED connected to port B. That level of direct control is what makes embedded C perfect for microcontroller applications. Our our washing machine simulation required such control for triggering cycles, updating displays, and responding to user input in real time. So, what is embedded systems? An embedded system is a compact computer designed for one specific purpose. Examples around us include microwave ovens, digital watches, ATMs, and of course, washing machines. Unlike a laptop that can perform multiple tasks, an embedded system is optimized for just one thing. In this case, running a washing cycle. They have which have the following characters in embedded systems: dedicated functionality. It only performs one function: real-time response. It immediately responds to input. Example: stopping the wash if the lid is opened. Third one, compact and efficient, which uses minimal power and memory. So in our project, the embedded system monitors user input from the keypad, displays messages on the LCD, and activates the buzzer, all in a time-controlled sequence. This mirrors how a washing machine functions in real life. So next, coming to objective of the project. So our main goal was to simulate a complete washing machine system on a microcontroller platform. We aimed to show how embedded systems are applied in everyday appliances. And the next one is to understand how to integrate multiple peripherals like keypads, displays, timers, and buzzers. To implement interrupts and timers to make operations dependent and responsive, and to apply modular coding practices in embedded system. Beyond just running code, we wanted to simulate real world behavior. The system should allow a user to select a mode, run the cycle in timed stages, alert the user when it's done, and handle invalid inputs or stops. This helped us understand not just programming but also system design and integration. So the tools which we have been used in this project are MPLab XID, XC8 compiler, PiximLab, which are of three. So the MPLab is where we wrote and debugged our code. It supports C and embedded C and provides a friendly interface for compiling and managing projects. So coming to XC8 compiler, which converts the C code into binary machine code that the microcontroller understands that the PIC microcontroller understands. So coming to the last tool, Pixum Lab, which is most exciting tool. It simulates actual embedded hardware like microcontrollers, keypads, LCDs, and buzzers. It's open source and allows you to test your design virtually. No need for wires, breadboards, or external power supplies. You can see outputs on a virtual LCD and hear buzzer alerts just like on a real device. Using these tools made the development process seamless and safe without damaging any components. So the microcontroller which we have been used in this project is PIC16F877A. So the PIC16F877A is a microcontroller which is an 8-bit microcontroller which is widely used in educational and industrial projects. It's part of microchip's PIC family. So here's why we have chosen this microcontroller is it has 33 input to output pins, timers, ADC, USART or I2C support, W prom. So when it comes to 33 input to output pins, which is used to connect multiple inputs and outputs like the LCD, keypad, and buzzer. So coming to timer, it is essential for running the washing cycles with time limits. ADC. We didn't use analog sensors in this project. This microcontroller supports analog to digital conversion, making it future proof. So coming to I2C support, which is useful for communication with other modules or displays. So EEPROM, which can store data like cycle count or preferences even after power loss. These are the tools which are robust, which has robustness, well documented chip, and it integrates well with MP Lab X and Pixim Lab, which is why it was perfect for our simulation. So the components used in this project are switches, keypad, CLCD, timers, interrupts, buzzers. So the switches acts as basic on and off and emergency stop buttons. When it comes to keypad, which allows users to input commands like selecting wash modes, setting cycle duration, or stopping the machine. CLCD is nothing but character LCD, which displays messages in real time. For example, during washing, it might display washing 3 minutes remaining. So the next one is the timers. Timer is internally configured using the microcontroller. These keep track of washing, rinsing, and drying durations. Interrupts. Interrupts allow the program to pause current tasks and handle urgent inputs like an emergency stop. So coming to buzzer. Buzzer alerts the user when the wash cycle completes or if something goes wrong. All of these components are virtually simulated in Pixim Lab and their connections are emulated to behave exactly like a real circuit.
So I'll take over from now on. As far as the block diagram of this project is concerned, this slide presents a block diagram of a microcontroller, which is used to which is used to stimulate the washing machine. The main purpose of this diagram is to give a user a simplified and a outer picture of what happens in this stimulation, and to give an overview of how various components are interconnected within the microcontroller and how they communicate with each other. At the center, if you can clearly observe, we have the PIC16 16F877A microcontroller, which is the main part of the system, which or else you can call it the main brain of the system. It controls all operations by executing the program written in embedded C, which my friend has explained earlier. On the input side, we have a 4 into 4 keypad, okay, which allows users to input commands such as selecting the wash mode or starting and stopping the machine. The push buttons uh, or switches, which can be used for powering on the system or initiating an emergency stop. These inputs are received by the microcontroller through its digital input pins. On the output side, we have a CLCD, which is nothing but a character LCD. Typically, it is around 16 into 2 to display the real-time status. And I mean, the messages like the washing machine is running, I mean, rinsing, washing, and if it is completed, then the cycle complete. It is used to display the real-time status of the washing machine. Next, a buzzer. A buzzer is which gives an audible alert when a cycle finishes or if an error occurs. So at the end of the washing, the the buzzer gives a slight sound so that the user can understand if the washing machine is complete or not. The microcontroller also uses its internal timers to manage the time-based operations of different washing phases. We configure interrupts to handle events like button presses or timer overflows or allowing the system to respond instantly without continuous cooling. The architecture makes the system modular, responsive, and easy to debug. All work is in sync under the control of the microcontroller to stimulate the behavior of a fully automated washing machine. So here are the sample outputs which we'll be demonstrating in our next step. So the first would be the power on. I mean, there will be something called key 5, which will be on the PICSIM lab, and this is the 16 into 2 CLCD which I mentioned before. On this, the main information and the status of the washing machine is represented. So uh, after pressing the key 5 on the PICSIM lab, you will be able to power on the washing machine. After that, it displays you various washing programs, which include daily, heavy, delicates, or any other. You can customize it according to your need. And upon pressing the key 5 again, it will scroll up and down. Same with the water level. The most used is the auto water level. So it is considered as efficient way of using water in real life. So, but upon your need, you can shift it to low or medium. The next is the switch. In the block diagram, when you clearly visualize, uh, after after selecting the options, the next would be the switch, in which you press SW5 to start the washing machine, SW6 to stop the washing machine. And after starting the washing machine, the display would be something like a function wash, and it also shows the time how much it will take to complete the entire process. The the 5 button is used for start and 6 is for pause. Whenever any external disturbance is occurred, whenever there is any disturbance from outside, then which may cause the door to open, then the display shows that the door is open and asks the user or indicates the user to uh, close the door so that it can resume the process. After this entire setup, after entire washing, the program is completed, and it gives the user an indication to remove the clothes. at the end point, the buzzer comes out, which indicates that the entire process is completed. So now if you go to the MP Lab X IDE, you can see uh, what all the codes we have written. So these are the header files, dcdh, main h, and digital keypad, etc., and timers. The washing machine header is written under the header files, and the source files, if you can see, has an dot c at the end of it, which indicates that they are the source files, and which are represented as shown. This is the main c where the program is written. And now if we switch to the working, we can see that yeah, you can play the video. So So you can see that there are several options when you start the washing machine. Before starting the washing machine, you need to load the hex file, which I already loaded. And then you need to select the board, the Pick Genius, which I already selected, and the microcontroller from the microcontroller tab, which I already loaded it before. Uh, and the microcontroller, the Pick 16F877A. When we press the button reset, it kind of refreshes, and then it will give you the desired output. And then after pressing the key 5, it gives you different washing programs, upon pressing the RP3, which is the button, it switches it between the different white programs. When you long press the RB3 button, uh, it will be able to select the desired program of the user. The desired program of the user will be selected. Uh, so now I'll select the program. You need to wait for 2 seconds in order to select. Now, after selecting the mode, you need to go to different types of modes in the water level. Same even here, it will switch between the level between the options when you press RB3 button. And if you long press an RB3 button, then it will go to the desired selected level. After long pressing the auto button, it will go to the switch, in which the SW5 is pressed in order to start the washing machine. And after pressing that, the washing machine runs. As you can see, the fan is moving. I mean, it is in some movement. So in order to stop the washing machine, you need to press 6. And in order to start it again after after pausing the washing machine, you need to press 5 again. So that's how it operates. And if there are any disturbances, the screen will show as I showed previously. Let us wait until the wash. It even has some timers which shows the function also. After some time it will go to rinse, and after some time it will go to completed. After the timer is completed, automatically the washing machine is stopped, and it also gives a message on the LCD screen uh, to remove the clothes. Yeah, thank you. And lastly, thank you to the emergency for taking this giving us this a wonderful opportunity to interact with such great people and different softwares. And we'll be looking forward to associate with them again. And yeah, thank you so much.